Where's the center of the universe? Trick question. If I zoom out far enough, every direction looks roughly the same, and no spot is special. The Big Bang didn't explode from a single point into empty space. It happened everywhere at once. Space itself expanded. So from any galaxy's point of view, it feels like the center of its own observable bubble. That's not ego, that's geometry. Now, if you meant galactic cores, that's a different story. Those do have a center, usually a supermassive black hole. Ours is Sagittarius A, buried inside a dense stellar bulge, not a ball of iron nickel. Okay, let me try something more speculative. A kinetic grid way to think about gravity, mass, and expansion. Imagine space as a high-pressure grid of tiny, immutable nodes, not an empty vacuum stretching like taffy. In this view, expansion isn't space thinning out, it's a persistent pressure effect. Think of it like a universal headwind nudging galaxies apart. Some fans of this idea talk about a 2:1 propagation ratio. Interactions ripple through the grid in a way that produces a steady Hubble drag. The grid stays static, the pressure waves move matter. What about mass? Instead of being a built-in stuff, mass could be the frequency of mechanical interaction between matter and those grid nodes. Push harder, interact faster. That's what feels like inertia. In standard relativity, we say relativistic mass increases as you approach light speed. But here's a twist. If a propulsion system could cancel the grid's resistance, like hydrodynamics for spacetime, it might accelerate without that apparent mass increase. Gravity, reimagined. Not a spacetime well, but a region of slightly lower pressure. Matter displaces grid nodes, and the resulting gradient pulls other matter inward. More suction than curvature. That's a very different mental model, but it aims to reproduce the same falling behavior we observe. Some versions add a graviton node, a unit of pressure. As matter moves, it must shove past these units. If you could manipulate the carrier field so your engine slips between nodes, avoiding the usual mechanical hits, you'd feel less inertia. Call it a massless engine, not because the ship is massless, but because the resistance is neutralized. To be clear, this grid framework is a hypothesis, not the consensus. General relativity and the standard cosmological model match observations with stunning precision. But as a thinking tool, pressure, not gravity, is a fun way to poke at first principles. No universal center. Galactic cores powered by black holes. And maybe, just maybe, a universe where motion is all about the music of the grid.
What I wish I knew at first. Space expands from below, not sideways. Think pressure, not rubber. That flips everything. Start with the 2-1 rule. Expansion isn't subtle. It drives massive horizontal flow across the cosmic surface. Big blue arrows in our panels show that lateral rush. Expanse velocity, sloshing like a tidal current. That high-speed fluid wash floods low-pressure wells faster than a planet can push back. The dashed well profile? It's not deep anymore. It's flattened, eroded by relentless flow. With the geometric anchor gone, planets can't stay nestled. They slide into a buoyant, straight alignment. Compare the two insets. Einstein's geodesic is a carved-in trap, deep, fixed. The kinetic fluid alignment is temporary, drag rules, and the ball just skates along a smooth, unstable surface. In short, expansion as bottom-up hydraulics redefines cosmic structure, fabric tension, fluid dynamics, and suddenly gravity looks a lot less permanent.
After all, we all come from a bunch of monkeys.
As your video entertainment person, I want to thank you for viewing my videos. I encourage people interested in advanced physics dialogue. Hope you enjoy this video about faster than light space travel.